Okay, so this four-way reversing valve is the big part of what makes all this happen, so let's talk about it first. This one here is a pipe by itself. What is that going to be? Discharge line. Always, always, always. Now, what if it's installed like this? What is it going to be? Discharge line. What about if it's installed like this? What's it going to be? What about if it's installed like this? What's it going to be? What about this? What about this? What about this? What about this? It's always, 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 always discharge. Now, of the three pipes, the one in the middle, what's the one in the middle going to be? Suction line. What about now? What about now? What about now? What about now? Now. See, no matter what, it's always going to be that. So when you're looking at one, you're like, oh, I can't remember what's what. Well, the one in the middle is always discharge coming out of the compressor. The other one is always going to be suction going back to the compressor. Now, inside, those pipes never touch each other. But that's how it pipes in. Now, what changes are these two. One will be going outside, one will be going inside. All right? So what happens is inside of here, this is what we have going on. This is our valve. It slides back and forth. It's a very simple little concept. And everybody will get to see it. It's okay. But what we have is a little cup right here. See if I can draw it for you to see. So I got a pipe here, and a pipe here. Should draw these a little bit closer, maybe. HVAC technician. And then some.
I'm disrespecting like that.
All right, so here we go. This is what we have are three pipes, correct? Look kind of like what I'm trying to draw? Just say yes. All right, so here there's a little cup right here that fits on a track. So if these are cupped, that means suction is always going to be going this way, right? Now, if those two are cupped together, and this is discharge, where's the discharge going to go? It can only go to this way, right? And then if I move that little cup the other direction, so now it's cupped over here. Yes. Then it's flowing this way. And if that's happening, what's this high pressure? Where's the high pressure going to go? That's right. How cool is that? All this thing does is slide this way, slide to the left, or slide to the right. Slide to the left or slide to the right. Yes?
What makes it slide? Is that electric?
Oh, that's a great question.
We'll get there.
But we're just a little bit. Let me finish up this. But it just slides back and forth. That's all it is. Very simple little concept. Right? Just slides back and forth. No big valves move, nothing else. And also, where this little cup is, there's a piece of Teflon around it, and there's a block of brass right there. So what happens is the high pressure that's pushing on that cup all the time keeps that cup sealed to the bottom. The high pressure on one side keeps that cup pushed down, and the lower pressure on the other side helps keep that sealed. One big problem is people will be brazing or do whatever work on here and they overheat it. And what happens to Teflon when you get it too hot? It melts and it will bubble up. And that's one problem that you'll have with these. Other than that, they're very simple. They just slide either to the right or to the left. To the right or to the left. Now the next question is, what makes it slide? What makes it move? And what makes it move is pressure. So that little cup is what makes it connect. But what we do on top of that is on the sides of it, I have these little channels right here.
That's my channel.
So what we use is we have high pressure. Now if I put high pressure on this side, what it does, and I put low pressure on this side, it causes this slide to push this way. And then if I change and put high pressure on this side and low pressure on this side, it causes it to slide the other way. So we use pressure to make this move. Pressure makes this move. I need 100 psi difference, approximately. But if I have high pressure on this side and low pressure on this side, is that going to want to push this way? Yep. What about if I put high pressure on this side and low pressure on this side? Goes the other way, right? So pressure makes this thing move. So the next question is, how do we get the pressure to the different sides, right? That's where we need a pilot. Well, let me explain this, and we'll go back and answer all your questions. Otherwise, we'll get lost in the. So what happens is we need a pilot, somebody to guide this action. No questions yet. Let me finish this up. Okay. So what we have here is another reversing valve on this back side. It's a little miniature reversing valve. Little miniature reversing valve. So what this has is a little bitty bitty pipe that's connected to the side that's always discharged. Because what pressure is that going to be? Always high pressure. Then I got a little pipe on this bottom side. What pressure is that going to be? Low. Always low pressure. And then I got a little pipe going on this side and a little pipe going on this side. What we use here is a solenoid valve, an electromagnet. That electromagnet is going to move a little bitty piston here. That causes this high pressure to go through there, and then this can connect the high pressure to this side. At the same time, it connects this low pressure to this side. So it uses the high pressure over here to push the valve this way. Then when I disconnect the electromagnet, the spring closes and it goes back and it connects the high pressure to its normal side on this side, which makes the low pressure here connect here, and then it moves the slide back the other way. It's called a pilot valve. It uses a small solenoid with a small spring inside to make the refrigerant change to move the big valve the other way. Now I could use a big solenoid here to make it happen in a big spring, but that would be a giant solenoid, a really big electromagnet, a big spring, a lot more copper, a lot more expense, and a lot more space. By this, using a small electromagnet here, I use a 24-volt electromagnet. I use the high pressure that's already available to make this valve slide back and forth. That make sense? It's called a pilot valve. I use the high pressure to make the slide move. So with that being said, if I energize this electromagnetic coil without the compressor running, will this slide move? No, the compressor has to be running. The reason I say this, I had a guy that called me once and said, "Hey, Tom, I'm having trouble with this valve. I just replaced this reversing valve. Before I put the refrigerant in, I wanted to check it to make sure it's working. And it's not doing anything. It's not moving. The valve's not moving." Like, well, it's not going to move because you have to have refrigerant in and the compressor working. Because all you're doing is hearing a little click here, clink, clink, clink. It's not making the whole valve move. Because what makes the valve move? Pressure. We're going to have a pressure difference. And if the compressor's not running, we're going to have a pressure difference? No. Right? Isn't that cool? So this valve moves because of the pressure between the high side and low side. It uses the pilot valve to make the pressure move to make the big side move. This little solenoid valve makes it change. So it's normally in one position, and when it energizes the solenoid valve, it changes it, puts high pressure on the other side, makes it move the opposite way. Pretty neat, huh? Now questions.
So you were talking about the Teflon that's inside. Is there any way that it wears out by itself?
No.
No?
There's oil in there with the refrigerant. It'll never wear out.
Okay. Unless you're raising people.
Yep. What will cause it to go bad is contaminations. People brazing without running nitrogen through. We haven't done that yet, but when we braze, remember how you guys had all that black stuff on the outside of that pipe? Yeah. That's called oxidation. And that oxidation happens on the inside of the pipe as well. And that oxidation, remember how those buckets are all and they're dirty and nasty, those rags are dirty and nasty? Mm-hmm. Well, that oxidation floats around in the refrigeration cycle and it gets clogged up in things like these little bitty tubes right here. That's what causes them to go bad. So to prevent oxidation, we need to prevent oxygen from being inside the pipe while we braze. So what we do is we free flow nitrogen through there. By having nitrogen only, can we have oxidation? No, there's no oxygen. So when we braze with nitrogen in the system. We'll learn that before we leave. That way when we're brazing, we don't have oxidation. Without having oxidation, there's no contaminant. So if I keep the pipes clean, keep them flushed, keep all the, like when we deburr it, we make sure none of those shavings get inside, because all that contamination is what clogs up these little tubes. These little tubes get clogged up. Then as the tubes get clogged up, the valve won't move.
The 24 volts that's feeding that, does it come from the thermostat?
Yes. There's a switch in the thermostat, just like the thermostat connects R to Y to G. It also connects it to another terminal, which energizes this valve, depending on what brand. We're going to talk about that too when we get to the wiring side. Is it simple? It is, right? It's pretty simple. It's just a valve that either connects these two pipes, and by default these two connects, or it moves over and connects these two pipes, and by default these two connects. It uses the high pressure to make that happen. Keep it clean, and it's simple. They're very, very, very simple. People want to make them complicated because they don't understand what's happening inside.
What's the name of that piece again?
It's a four-way reversing valve.
Four-way reversing valve.
Four-way reversing valve. In the field, people just call them typically reversing valves, but in reality, it's really, truly a four-way reversing valve. A four-way reversing valve. Cool, huh? Isn't that awesome?
Yeah.
A four-way reversing valve.
Between that and the
It's-
two check valves, it's able to.
And the check, we'll get to check valves here in a little bit.
But between
Yep.
those two and that, it's able to
Be a heat pump.
completely reverse the system.
Absolutely.
So when would you know to use the muffler? Is it any time you use a?
You can put a muffler in any system. It doesn't have to be a heat pump. Some manufacturers, it's not like we're going to go and say, hey, Angus, man, your unit doesn't have a muffler on it. We need to add that. It's nothing that you would ever do. And I've never seen a muffler go bad. It's either there from the factory or it's not. The manufacturer designs thousands of stuff, and they thought, well, we got so much of a pulsation vibration here, we need to add that, or they don't think it's enough and they don't add it. So it's just one of those things we don't have to worry about. Remember in the lab, we went in the lab and we saw the compressor cut open, and right off the discharge line, we saw a tube that came to a larger point and a smaller point. That's the muffler inside. Let's go look at that.